run it through a 1 proportion z interval for a population proportion. So the idea is we are going to be making a confidence interval to try and estimate and pin down what exactly the population proportion is. So in our example here, we have at a high school of 5,000 students, some AP students want to know the proportion of all students who buy lunch. The AP students collect a random sample of 80 students and find that 24 of the students buy the school lunch. Construct and interpret a 95% confidence interval for the proportion of students who buy lunch. So basically what's happening is these AP students have a sample of 80 students and have a proportion from that. What they're trying to do is use that sample's proportion to estimate the entire population's proportion. So they want to know for the entire building, all the high school students, what proportion of students actually buy the school lunch. So we've talked about this in class. The best way to work through confidence interval problems is to work through our acronym PANIC, P-A-N-I-C. So the first thing we need is going to be parameters, then assumptions, then name it, then do the interval, and then context. So I've already worked out this problem to save us a little bit of time. The first thing I would do in this problem is I would work through and pull out the relevant information. So we know our sample size is 80, so I'm pulling out, hey, n equals 80, and then I know my sample proportion, p hat. So they told us 24 out of 80 students buy the school lunch, 24 out of 80 being 0.3. So I pull out my n and I pull out my p hat. Once I have those pieces, I'm ready to start moving through PANIC. So the first piece is we need to write down our parameter. Since we're dealing with proportions, we're using P for the population proportion. So P is the proportion of students at school who buy lunch. This is what we're trying to pin down. This is what we're trying to construct our confidence interval about. We're trying to figure out the proportion of students at school who buy lunch. Okay, define that. The next thing I'm going to do is I'm going to go through the assumptions, because without these assumptions, this whole problem essentially falls apart. Okay, the whole problem falls apart. For proportion problems, our 3 assumptions are independence, 10%, and we're going to be checking NP and NQ is greater than or equal to 10. So the first thing I did is independence. To know we have independence, we want to make sure our sample was randomly selected, which if you read through that problem again, yes, the sample was randomly selected. Then we're checking this 10% condition, which is working with the independence there. It's helping prove independence. We need to make sure our sample is not too big, okay, not too big. So my sample of 80 is less than 10% of the population. How I know this is they did tell me the population size is 5,000. So if you have a sample of 80 and your population is a size of 5,000, you could do a quick check on a calculator to know, hey, that's definitely less than 10% of the population. This third condition is the one that you really need to be careful on because it switches based on what we are doing. Okay, when I originally ran through the assumptions for proportions, I said, yes, we're checking NP and NQ are both greater than or equal to 10. We don't know P yet. That's the population proportion. We don't know P. So in cases where you don't know P, we're going to use P hat instead. So what I checked is NP hat and NQ hat are greater than or equal to 10. I do have to do a little bit of quick math here using my numbers up above, and I find that yes, I get 24 and 56, which are both greater than or equal to 10. What I'm trying to prove here is my sample big enough? Okay, is it large enough? Because all of these assumptions are met, I know I can proceed with my problem here, and I know the formula is going to work out. All these pieces they affect different parts of the formula and what would be thrown off and what's not. When they're all working together, our entire formula is going to be working together here. So my assumptions are met. That means I can move forward with the type of problem I'm trying to do, which is a 1 proportion z interval. We're doing a 1 proportion z interval. The next piece I did is I plugged in and actually found my formula. Reminder, for a 1 proportion z interval, our formula is p hat plus or minus z star times the square root of p hat times q hat over n. Now, I didn't write out my formula all in symbols. Obviously, I showed it to you here. I just went ahead and plugged all of my numbers in. So I have 0.3 for p hat. Z star is entirely based on confidence, and it's entirely based on confidence. So when they say we want a 95% confidence interval, I know my z has to be 1.96. That's where that number came from. Inside my square root, I have p hat times q hat, so 0.3 times 0.7. And on the bottom, the denominator, I have my sample size, which is 80. So this is my formula for my one proportion z interval. And then I'm going to pull this paper entirely away. I let my calculator actually handle this calculation for us. Okay, and I'll show it to you here in a second. And I got my interval as 0.1996 to 0.4004. So we'll wrap up the problem and I'll show you where this is found in your calculator. So this is my interval piece of panic. We finally need to pull it all together with context. So I said we are 95% confident the true population proportion of students who buy lunch is between 0.1996 and 0.4004. So essentially we're saying, I believe, and I'm 95% confident on this, that between 19.9% of students at this entire high school and 40.04% of students actually buy the school lunch. So the true proportion of students for the entire building is between 19.96% and 40.04%. That's what it means. Additionally, when we're talking about 95% confidence, again, that 95% means if I sat here and collected sample after sample after sample, get a sample, get an interval, sample, get an interval, sample, get an interval, and do that over and over and over and over again, 95% of all the intervals I create will actually capture the true population proportion. Okay. The final thing I want to do in this video is just show you real quick, how can you do this in your calculator? So you have it in front of you. What you would be doing is you'd be going to our stat button, which is where we are at home for a lot of things. You go all the way to the right to tests. And what we're looking for is that one proportion z interval. So you could start scrolling down. There's a lot of different options in here. And we want the one proportion z int. Right there, it's option A. What you're going to enter is you're going to enter in your fractions. So the x is the top part of your fraction for p hat. So 24 out of 80, 24 over 80. Your confidence level, we are a 95%. If this was to change to 90%, then you want to type in 0.90, okay? And then you can hit calculate. It's going to produce your interval for you. It's going to tell you what your p hat is. It's going to tell you what your n is. So when I constructed this problem, I had this kind of sitting in the background for me to peek on, okay? So that is a full working out of a one proportion z interval for a population proportion.